The issue at hand involves the proper installation of electrical equipment, specifically regarding a rooftop unit, or RTU, and adherence to the National Electrical Code (NEC). There are two primary areas of concern: firstly, the sizing of the circuit breaker protecting the RTU, and secondly, the color coding of the conductors used for both high and low voltage applications. Let's address the circuit breaker sizing first. The NEC, specifically Article 110.3, mandates that electrical equipment be installed in accordance with its listing and labeling. This means that if the RTU nameplate specifies a maximum circuit breaker size of 35 amps, then a 35 amp breaker is the correct choice, regardless of any other factors or engineering opinions. Using a 70 amp breaker, as the engineer in question has specified, directly violates this code requirement and poses a significant safety hazard. Overcurrent protection devices, such as circuit breakers, are designed to protect equipment and conductors from damage caused by excessive current. If the breaker is sized too large, it will not trip in the event of an overload or short circuit within the RTU, potentially leading to overheating, fire, or equipment failure. Think of it like this: if you have a device designed to handle a maximum of 35 amps, and you allow 70 amps to flow through it unchecked, the device is likely to be damaged. The circuit breaker is the safety valve that prevents this from happening. Now let's consider the conductor sizing. The NEC also dictates how conductors must be sized based on the ampacity of the connected equipment and the length of the run. In the scenario presented, a number 2 conductor is specified for a 50 amp RTU on a 100-foot pole. This is likely also a violation. To determine the correct conductor size, one must consult NEC Table 310.16, which provides ampacity ratings for various conductor types and sizes based on insulation type and installation conditions. The ampacity of the conductor must be equal to or greater than 125% of the RTU full load current rating, or the rating of the overcurrent protection device if the overcurrent protection device is rated at less than 100 amps. In this case, a number 4 conductor may be sufficient. The important takeaway is that the conductor size must be adequate to safely carry the anticipated current without overheating, while accounting for voltage drop over the length of the run. The longer the run, the larger the conductor may need to be to minimize voltage drop and ensure proper operation of the equipment. Using too small of a conductor can lead to voltage drop, which can cause the RTU to operate inefficiently or even fail prematurely. Next, let's discuss conductor color coding. The NEC, particularly Article 240, requires that all systems and phases be clearly identified through color coding. This is essential for safety and for facilitating proper maintenance and troubleshooting. The standard color code for alternating current, or AC, power systems is as follows: black for phase A, red for phase B, blue for phase C, white for the neutral conductor, and green or bare copper for the grounding conductor. Using the same colors for both high and low voltage applications, as the engineer has specified, is a clear violation of the NEC and creates a dangerous situation. It can lead to confusion and accidental contact with energized conductors, potentially resulting in electric shock or electrocution. Color coding helps electricians and other qualified personnel quickly and easily identify the different conductors in a system, allowing them to work safely and efficiently. It is a fundamental safety practice that must be followed. In summary, the engineer's decisions regarding circuit breaker sizing and conductor color coding are incorrect and violate the NEC. The RTU must be protected by a 35 amp circuit breaker, as specified on its nameplate. The conductor size must be properly calculated based on the ampacity of the RTU and the length of the run, referencing NEC Table 310.16. And the conductor color coding must adhere to the standard black, red, blue, white, and green scheme for AC power systems. It is crucial to address these issues to ensure the safety and proper operation of the electrical system. Failure to comply with the NEC can have serious consequences, including fines, legal liability, and, most importantly, injury or death. It is recommended to seek clarification from a qualified electrician or electrical inspector to resolve these discrepancies and ensure that the installation meets all applicable code requirements. Remember, The NEC is a comprehensive set of rules and guidelines designed to protect people and property from electrical hazards. It is not a suggestion, but a mandatory set of requirements that must be followed. Understanding and adhering to the NEC is essential for anyone working with electrical systems. Now let's dive a little deeper into each of these topics, starting with circuit breaker sizing. The purpose of a circuit breaker is to protect the circuit it feeds from overcurrent conditions, which can be caused by short circuits, ground faults, or overloads. When an overcurrent occurs, the circuit breaker trips, interrupting the flow of electricity and preventing damage to the wiring and equipment connected to the circuit. Selecting the correct circuit breaker size is critical for ensuring proper protection. If the breaker is too small, it will trip frequently, causing nuisance tripping and interrupting the power supply. If the breaker is too large, it will not trip in the event of an overcurrent, potentially allowing the wiring and equipment to overheat and cause a fire. The NEC provides specific guidelines for selecting the correct circuit breaker size for various types of equipment. As mentioned earlier, Article 110.3 requires that equipment be installed in accordance with its listing and labeling. This means that if the equipment's nameplate specifies a maximum circuit breaker size, that size must be used. In the case of the RTU with the nameplate specifying a maximum circuit breaker size of 35 amps, a 35 amp breaker must be used. There are no exceptions to this rule. It is also important to consider the inrush current of the equipment when selecting the circuit breaker size. Inrush current is the momentary surge of current that occurs when the equipment is first turned on. Some equipment, such as motors and transformers, can have very high inrush currents, which can cause the circuit breaker to trip even if the running current is well below the breaker's rating. To prevent nuisance tripping due to inrush current, it may be necessary to use a circuit breaker with a higher instantaneous trip rating or a time delay circuit breaker. A qualified electrician can help determine the appropriate type and size of circuit breaker for the specific application. Now let's move on to conductor sizing. The size of the conductor used to supply power to a piece of equipment must be adequate to carry the anticipated current without overheating. The NEC provides tables that specify the ampacity of various conductor types and sizes based on insulation type, installation conditions, and ambient temperature. The ampacity of a conductor is the maximum amount of current that it can safely carry continuously without exceeding its temperature rating. When selecting a conductor size, it is important to consider the following factors. Firstly, the ampacity of the conductor must be equal to or greater than 125% of the equipment's full load current rating. Secondly, the conductor must be protected by an overcurrent device, such as a circuit breaker, that is sized appropriately for the conductor's ampacity. Thirdly, the voltage drop in the conductor must be within acceptable limits. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to operate inefficiently or even fail prematurely. The NEC recommends that voltage drop in branch circuits should not exceed 3%, and voltage drop in feeders should not exceed 5%. To minimize voltage drop, it may be necessary to use a larger conductor size or to run the conductors a shorter distance. In the scenario presented, the engineer specified a number 2 conductor for a 50 amp RTU on a 100-foot pole. Without knowing the specific details of the installation, it is difficult to say definitively whether this is the correct conductor size. However, it is likely that a number 4 conductor would be sufficient. To determine the correct conductor size, it is necessary to consult NEC Table 310.16 and perform voltage drop calculations. A qualified electrician can help perform these calculations and select the appropriate conductor size for the specific application. Finally, let's discuss conductor color coding in more detail. As mentioned earlier, the NEC requires that all systems and phases be clearly identified through color coding. The standard color code for AC power systems is black for phase A, red for phase B, blue for phase C, white for the neutral conductor, and green or bare copper for the grounding conductor. This color code helps electricians and other qualified personnel quickly and easily identify the different conductors in a system, allowing them to work safely and efficiently. Using the same colors for both high and low voltage applications, as the engineer has specified, is a dangerous practice that can lead to confusion and accidental contact with energized conductors. It is essential to follow the standard color code to ensure the safety of personnel and the proper operation of the electrical system. In addition to the standard color code, the NEC also allows for the use of other colors to identify specific circuits or functions. However, it is important to clearly document any deviations from the standard color code to avoid confusion. For example, a control circuit might be wired using yellow conductors, but they should be clearly labeled at all termination points. The NEC also requires that the grounding conductor be either green or bare copper. This is to ensure that the grounding conductor can be easily identified and is not mistaken for a current carrying conductor. The grounding conductor is a critical safety component of the electrical system, as it provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electric shock. In conclusion, the engineer's decisions regarding circuit breaker sizing and conductor color coding are incorrect and violate the NEC. It is essential to address these issues to ensure the safety and proper operation of the electrical system. Seeking clarification from a qualified electrician or electrical inspector is recommended to resolve these discrepancies and ensure that the installation meets all applicable code requirements. Remember, electrical safety is paramount. Always follow the NEC and consult with qualified professionals when working with electrical systems. A thorough understanding of the NEC is essential for anyone involved in the design, installation, or maintenance of electrical systems. The NEC is a living document that is updated regularly to reflect changes in technology and industry best practices. It is important to stay up to date on the latest code requirements to ensure that electrical installations are safe and compliant. In addition to the specific code violations discussed in this scenario, there are many other important aspects of electrical safety that must be considered. These include proper grounding and bonding, overcurrent protection, surge protection, and arc flash protection. A qualified electrician can assess the specific hazards present in a particular installation and recommend appropriate safety measures. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Always de-energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, hire a qualified electrician to do the job. Remember, electrical safety is not a luxury, it is a necessity. By following the NEC and taking appropriate safety precautions, you can help prevent electrical accidents and ensure the safety of people and property. Always prioritize safety when working with electricity. Remember to consult the latest edition of the National Electrical Code for the most up-to-date requirements. Code requirements can change over time, so it is important to stay informed about the latest regulations. Additionally, local jurisdictions may have their own specific amendments to the NEC, so it is important to check with your local building department to ensure compliance with all applicable codes.